So the purpose of this video is going to be to help you come up with the functions in your car comparison problem. So let's say I have the following car. It's an Acura RSX and it gets 23 miles per gallon. We pay $950 a year for insurance and $700 a year for maintenance. And we want the total cost function. So this function, so let's say that f of x is going to be the total cost after x years. X years. Oh, so we need the initial cost of this car. Let's say it was the MSRP as the starting cost of a car. And let's say it was $30,000. So then the total cost after X years, well, we paid the initial cost, right? So it's going to be starting cost of $30,000. And then plus, well then every year we're going to have some certain number of dollars that we pay. So X is the number of years, and we're going to pay $950 for insurance, $700 for maintenance, and then we need to figure out what goes here for gas. So let's talk about that for a minute. This is going to be gas per year. Now that's not going to be the miles per gallon of a car. It doesn't make sense to add miles per gallon with money. These are both money. So we need to figure out the money we spend on gas, right? So let's assume for a minute that we drive 10,000 miles a year is a pretty standard estimate. So we drive 10,000 miles in a year. And gas costs $3.14 a gallon. Well, then what we need to do is figure out how much it costs to drive a mile. So my car, we know, it gets 23 miles for 1 gallon of gasoline. So 1 gallon of gas gets us 23 miles. This is miles per gallon. Well, and we know 314 gets us a gallon of gas. So when we multiply these two and simplify the fraction, well, we get 3.14 over 23 miles. Because remember here, 1 gallon cancels with 1 gallon. And then the fraction 3.14 over 23 reduces to approximately in blue this time, approximately 14 cents for 1 mile, or 0.14 for 1 mile. Well, if it cost me 14 cents to drive 1 mile, so 14 cents, and I'm going to keep writing this as 0.14 for 1 mile, and I multiply that by the 10,000 miles in a year, in 1 year, just like we did last time. Here, miles cancel, the unit of miles, and we just get 10,000 times 0.14, and that's going to be 1,400. So I spend $1,400 a year, $1,400 per year in gas, and that's what I needed to find for that last number in my function. So this $1,400 a year in gas is going to go right up here. So this is now 1,400. We figured that out. That's how much I spent on gas. Well, these are all in parentheses, and they're all money, so I can add them up. 1,400 plus 700 plus 950 gives me 3,050. So that's the extra amount I spend on my car in 1 year. I'm gonna group all of these. So this is going to become 30,000 plus 3,050x. 3,050 is this sum right here. So now I have my function for this Acura. If I'm graphing this function, well, this is in slope-intercept form. This 30,000, since it doesn't have the x, that's going to be my slope. No, that's going to be my y-intercept, excuse me. And my 3,050 is the slope. Something to keep in mind when you're graphing this is, again, I'm going to copy this. Something to keep in mind when you're graphing this. So this is my function, or f of x equals f of x. That I really just need the 2 points to graph a line. Since I really just need 2 points to graph a line, then I know my y-intercept is 0, 30,000. So let's go in, I think 10,000 is good here. 10,000, 20,000, 30,000. So there's my y-intercept for this graph. And then it goes up 3,050 every year. I'm just going to find one other point on here. So let's go out to 10 years. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And I should probably label my axis, my axes cost, and down here is years. So out to 10 years, well, 30,050 times 10, or f of 10. So if I just need to find one other point that's on this graph. So f of 10 would be 30,000 plus 3,050 times 10. Which is going to equal 60,500. So that means for 10 years, I'm going to go, this is 10,000, 30,000, 10, 20, 30,000, 40, 50, 60,000, all right? Cost in 10,000s years. So that means I just need this one other point up here. So is that about right? Now it's better. And then I can just go ahead and draw my line. All right? And of course that would keep going up. So there's an example of how to come up with your function for one of your cars and then draw the graph. Now I expect your graph to have, since you have more space, you could probably go in just thousands on your y-axis. But yeah, remember this assignment is due Friday because that's the last day of the 6 weeks. So I hope this was helpful.